Today we're going to talk about quadratic functions. I want to do a little bit of recap about some vocabulary, and then we're going to recap linear functions to kind of like compare them to quadratic functions. Okay, so first of all, we're going to be talking zeros and X-intercepts. All of our intercepts really mean, they're more meaningful with quadratic functions than they are with linear functions. So we're going to write our intercepts as ordered pairs, because remember, like let's say our zero, which is an X-intercept, let's say our 0 is 7, okay? That means that on the test, you're going to have 0, 7 as an option and 7, 0 as an option. And if it's a 0, this is the correct one because, remember, it's 0, its last name is 0. So we want to make sure that we practice writing them correctly so that we don't make that mistake, because they're going to give us the answer where it's written wrong. Okay, so we want to make sure that we always write our intercepts as ordered pairs so that we get into good practice of making sure, that way if we see an ordered pair as an intercept, we're not going to get it wrong. Okay, next thing, we just learned this, but the vertex is in the form of HK, and it tells us the axis of symmetry and the range. So it gives us, so the H tells us the axis of symmetry, and the K gives us the boundary of the range. Okay, so that is a very, very rich and powerful coordinate. Also, the term 0 means X-intercept. It is vital and critical that you know this. Okay. Now, this is something new, but I want you to know about it. In a quadratic, and we just talked about the parabola, and we just talked about how this parabola shape is what a quadratic function looks like. We're going to have either 1, 2, or no zeros. Okay. So if we have 1, 0. That means that our parabola is either sitting on or hanging off of the x-axis. Now, obviously, it's not always going to be over here or over there. It might be right here. But if it's sitting on or hanging off of the x-axis, then there is only 1, 0, because there's only one place that the parabola actually touches the x-axis. We might also have 2 zeros or x-intercepts, in which case this parabola touches in 2 places, this one also touches in 2 places. So my parabola actually crosses the x-axis in 2 places. So that would give me 2 zeros. And the last one will be no zeros, because in this case, the parabola turns around. So this one's going down, 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 whoop, it turns around, but it never hit 0, it never reached 0. Or in this case, it's going up, 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 and then it turns around and goes back down. It never reaches 0. It never gets to the x-axis before it turns around, so it never touches the x-axis. This is going to become more important as we move further along in this lesson. Okay, so let's talk about these notes. Now, we already did these notes. Okay, now we're going to go to these notes now. And what we're going to do with these is these are examples that we're going to use to help us kind of interpret what we just learned. Okay, so for this one, I have a table and a graph, and these tables and graphs are both the same thing. Okay, so this table represents this graph. So on the table, okay, so first of all, the information that I always collect, okay, and like every single time I do one of these, I write the same information down, okay. So I write down V, Y, Z, Z, AOS, R, N, G. Okay, you're like, what is this, another language? Yes, it is another language, okay? The first thing I'm going to do, we're going to start by looking at the table. For this one, we're going to start with the graph first, and then we'll go to the table, and then for this one, we'll start at the table and go to the graph. So we're going to find the information on our graph, and then we're going to confirm it on our table. Okay, so let's just kind of pretend that's not there. Okay, so if I look for the V, V is vertex. And remember, vertex is an HK format. So my vertex is my turning point, and I see it right there. Okay, and the coordinate of my vertex is 1, negative 1. So I'm going to write 1, negative 1. And what that also tells me, if we recall, we're going to jump down here real quick. That tells me what my axis of symmetry is, and it tells me what my range is. Okay? So remember, the axis of symmetry is the x part, or the h part. Okay? So this is my axis of symmetry. It's x equals whatever the x value is in my vertex. Well, the x is 1, so the axis of symmetry is x equals 1. And what that means is that there is a symmetry. This parabola, like the left half is symmetrical to the right half if you folded it along this, oh my god, that was the crookedest thing ever, if you folded it along this line. Okay. I also can tell what my range is. Remember, my range tells me what y values are acceptable here. Okay. And again, just pretend that we had arrows here because remember my software doesn't draw arrows. So this tells me what my acceptable y values are. Well, since this is pointing up, my y values are greater than or equal to the y part of my vertex, which is -1. And if I look at the graph, all my y values have to be bigger than -1 because it turns around before it goes any lower. So that's how I know. Remember, all that information I pulled just out of the vertex. So if I know this, I know the axis of symmetry and I know the range. All right, now let's look at the y. Y is my y-intercept. Well, I can see right here, I look at my y-axis, my vertical axis, and right here is where it crosses the y-axis at 0, 0. Now, what are my zeros? My zeros are my x-intercepts. Okay, so if I look for where my line crosses the x-axis, I see that it actually crosses twice. So there's my vertex, there's my y-intercept. I've also got my 2 zeros. Well, it crosses once at 0, 0. It crosses again at 2, 0. Now, please notice that I wrote these as coordinates because, again, I'm not trying to mess this up. I'm not trying to get this wrong. Okay? They're going to write, if they ask me for a 0, they're going to give me a coordinate that's 0, 2 instead of 2, 0. Okay? So we have to be very careful about that. The last thing that we can tell from looking at this graph is, does it have a minimum or a maximum? Well, it's pointing up. I can't go below this value right here. That means I have a minimum. Okay? The minimum is at 1, -1, or the minimum is -1. Now, I can see all the same information by looking at the table. Okay? So I see that when I look at this right here, I see that my vertex, we talked about how my vertex is surrounded by symmetrical pairs. So see how all these points are surrounded by symmetrical pairs. Now notice I got these two guys here. They don't have a symmetrical pair. That's just because I haven't found it on the table yet. I could backfill the table, and I'll show you how to do that in a minute. But right here, this one that's surrounded by symmetrical pairs but doesn't have its own, that is my vertex at 1, -1, which is the same thing I found here. Now, to find my y-intercept, I look for the value, the one that has 0 in the x position. I look for the coordinate with 0 in the x position, and I see my y-intercept right there. To find my zeros, I look for the ones whose last name is 0, and those are 0, 0, and 2, 0. So all the same information that I found in the graph, I'm able to find in the table. Now, I talked to you about what happens when I have one that doesn't have an order, that doesn't have a partner. Well, I can do the same thing, so let's just pretend that I'm going to build the table out to find this one. Well, if this, see how here, if this is a 0, its partner has a y0. If the y is 3 here, its partner has a y of 3. If this is an 8, its partner has a y of 8. Well, this guy here is a 24. His partner's a y of 24. Well, if this guy's a 35, that means his partner has to be 35 as well. And if I continue this pattern, I'm decreasing by 1. So I start at 1, 0, -1, -2, -3, -4, -5. So -5, 35, and 735 are a symmetrical pair. I could continue this one as well. See, I could do this. So if this is 48, then that has to be 48, has to have a y value of 48. If I continue the pattern, I get -6. So if they give me a table and they say, hey, so if they were to say to me, hey, what's the symmetrical pair of 8, 48, I could continue the table. I could continue backwards and find the symmetrical pair that goes with it. All right? I want you to try. So again, let's really quick. We're going to write V and Y, Z, Z, A, O, S, R, N, G. I want you to take a minute and I want you to tell me what the vertex, let's just have you tell me the vertex and the zeros. Okay, so again, we're looking at the table. If you looked at the graph, that's fine too, but I'm going to look at the table since I started with the graph last time, okay? So I'm going to start by connecting up my symmetrical pairs, okay? So there's those, I'm connecting Okay, well, the one in the middle that doesn't have a pair is my vertex. So my vertex is -2, 9. All right, now, the next thing it wants me to find is my y-intercept. Well, I look for the x value of 0, and that tells me that that's my y-intercept. So my y-intercept is 0, 5. Okay, now I'm looking for my zeros. My zeros are x-intercepts. They end in 0. Well, I see one here and one here. So I have 2 zeros right there. One of them is -5, 0. One of them is
Ms.
1,
Brooks,
0.
You have a visitor in the front office.
Miss Brooks has a visitor in the front office. Okay. All right. So that was pretty easy. Those were the easy ones. Now the axis of symmetry and range are still really easy to find. I use the vertex for that. So for the axis of symmetry, I'm looking at x. For the range, I'm looking at y. Well, the axis of symmetry is the line that goes down the middle of my parabola, creating symmetry, which means equal on both sides. And that line is at x equals -2, which is the h in my HK vertex. For the range, I look at the k. Well, I know that it's going to be 9. This is pointing down, so that means I have to be less than or equal to 9. If it was pointing up, I'd be greater than or equal to 9. Since it's pointing down, that means I have a maximum value that I can have in my parabola. Okay? Now, let's try this one. Okay, now this one's a little trickier. I want you to find me the vertex, and then I want you to find me the y-intercept, vertex and y-intercept. Okay? Go. Okay. I'm going to write these down. Vertex, y, z, axis of symmetry, and range. Okay, my vertex is at 0, -7. My y-intercept is also at 0, -7. Okay, and I can also see that right here in the graph. In the table. Sorry. This is where this point is surrounded by symmetrical pairs. Okay. Now my y-intercept also starts with 0, which makes this my y also. Now, here's the tricky thing, and I'm going to erase this just really quick so you can see it a little better, because my pencil's kind of thick. If you look at this problem right here, okay, I don't see a 0. So in this case, I don't have a precise 0 because my 0 is between 2 points. Okay? Now remember, if I look here, I can see right here, there has to be a 0 here. So between -3 and -2 for my x values, I have to have a 0. Why? Take a moment. I want you to answer the question and tell me why I have to have a 0. Hopefully what you came up with was the reason I have to have a 0 is because I can see right here my y value, which is the last name of the 0, where it's a 0. Here it goes between, so it goes -3 and then it goes up to 2. In order to get from -3 to +2, I have to pass through 0. So there is a 0 between -2 and -3. Now, which one is it closer to? Well, I think it's closer to -3 because it's 3 away from here and it's 2 away from there. And if I look at the graph, if I look here, I can see that it's closer to -3. The reason why I care about this is because what if they say, is the 0 -2.2 or -2.8? Well, this one is closer to 3, so I'm -3, so I'm going to pick this one. Okay, now I don't think they do that, but they could. All right, tell me where you think, based on what we just talked about, take a second, I want you to tell me where the other 0, what x values the other 0 lies between. Okay, hopefully you did the same thing. You see that here it goes from -3 to 2, so that means there has to be a 0 right there between +2 and 3. Okay? So again, if it's between, which one is it closer to? Well, it looks like it's closer to 3 on this side as well, and I can see that also on the graph. Okay, what's my axis of symmetry? Actually, you tell me, what is my axis of symmetry? X equals what? Okay, so I look at the x value in the vertex, x equals 0. And tell me now the range. Okay, so for the range, I look at the y value. So I have y. It's pointing up, so it's greater than or equal to -7, which is the y part of the graph. I also know that I've got a minimum here because it's pointing up. And that means I'm never going to go below -7. That's just the minimum value I can have. I'm going to save this one. We're not going to worry about this one for now. We can do this another one. If we need another example, we'll save this for class. Have a good day.